Good day. This is a webinar regarding model-based system engineering and whether it's right for your company. Appreciate your participation today. What we'll go over in the webinar today is a definition of MBSE, why use MBSE, some of the barriers to entry, whether MBSE is right for you and your company, and getting started with MBSE. A little introduction about myself. My name is Robin Rose. I'm an advisory system engineer at Base2 Solutions. I have 32 years of experience in system engineering on a variety of programs, both with NASA, the Department of Defense, and commercial aircraft companies. We'll start off today about what is SC, system engineering, versus MBSE. The core of system engineering are the system engineers. System engineers at the heart of creating successful new systems. They're responsible for the system concept, architecture, and design. They analyze and manage complexity and risk. They decide how to measure whether the deployed system actually works as intended, and they are responsible for a myriad of other facets of system creation. System engineering is a discipline that makes success possible with the tools, techniques, methods, knowledge, standards, principles, and concepts. Model-based system engineering is an evolution of system engineering methods that uses models in place of documents. So it's very model-centric instead of document-centric. The models help improve outcomes for development projects that are too complex and difficult for traditional approaches. A recent economic analysis performed by Azad Madni and Shatad Purohit of the University of Southern California shows that projects with high levels of system and environmental complexity paired with long product life present the greatest opportunity for cost savings with MBSE. These types of projects still tend to reside in highly regulated industries such as aerospace, defense, medical devices, and transportation. The progression of traditional SE to MBSE compared to the transition from hand-drawn and 2D designs to today's powerful CAD systems. It's a natural evolution of the discipline. But just put more simply, MBSE is just system engineering using models. There's some core tenets of MBSE that are important to understand. The first is that definition is through models, not documents. Because documents are independent and disconnected, building a complete picture requires reading through many documents, then synthesizing the information on your own, which is time-consuming, error-prone, and only benefits the person doing the analysis. A model provides an integrated representation of the system and a common language and structure that maintains the relationship between the various parts. The second is that there is a single model of any system, but that model can be viewed through many different lenses or diagrams. Diagrams allow us to view the system from many perspectives, each offering key insights into the system and development effort. Third is standard language. Every engineering discipline has its own language, as do many teams and groups. MBSE provides a common language across the program that is specific enough to ensure effective communication, but flexible enough that each engineering domain and team can relate it back to their own language. This improves communication and reduces risk of misunderstandings. Fourth is the idea that there should be a single source of truth and a centralized repository of information. With MBSE, everyone uses that same source of information as the truth. It's the one model. And everybody has the ability to query that source of truth in any way that's needed. This prevents having multiple sets of books and ensures consistent understanding across the team. The ability to query that model, that is, clicking on any object in the model and see how it relates to everything else, is a huge benefit of MBSE versus document-based methods. Finally, it's important to understand the relationships between all the different parts of our system and understand how they impact our development efforts. The structure of the model helps us see these relationships. This improves communication, allows us to make more informed decisions, and help us see the up and downstream impacts of decisions we make that wouldn't be clear without the model. Before we go further, it's important to define a few terms. I'm going to discuss methodology, model, and diagrams, because these are terms that come up when discussing MBSE. Methodology is a set of methods, principles, and rules for how we perform system engineering through the use of models. A model is a representation of the system being developed. It's important to note that there's always a model, but often it's simply a mental model that's only useful to the person whose mind created it. MBSE is about creating a model that is useful by all and that requires 4 critical elements. Vitek, a company that makes MBSE tools, describes these elements as follows. A model must provide common language, which is essential for communication. A model must include structure, which allows information to be captured consistently with clear understanding of interrelationships. A model must support argumentation, which means that the model must help us make the argument that the system does or does not accomplish its purpose. Finally, a model must allow us to present the information in a way that can be consumed. The last term is diagrams. Diagrams are like lenses that offer different ways to view the world and view the model. The various modeling languages like SysML or OPM each include their own diagram types. These different views allow us to gain specific insights into our system model and together support the overall development efforts. Every system we develop has three sides: requirements, which frame the need and the capabilities, characteristics, and constraints of any appropriate solution; structure, which defines how the system is constructed or built; behavior, which defines what the system needs to do either on its own or in response to some external stimuli. A system model incorporates all three of these. Different diagrams offer unique ways to view the system model within each of these three contexts. Each diagram is like a lens that filters out certain information and lets other information through. For example, there are behavior diagrams that help us understand use cases, system states, or functional flows in terms of things like inputs, outputs, functions, and triggers. There are structural diagrams that help us understand both the internal and external structure of our system in terms of things like components, interfaces, links, and objects. Because all these diagrams are simply different ways of viewing the same model, they are all interrelated and need to be considered as such. MBSE allows us to see and leverage these relationships. So why should you consider using MBSE? By using standardized models, agreed upon methodologies, common architecture, modeling language, and a central repository, you can improve communication between stakeholders and eliminate ambiguity. It also addresses system complexity. By using models, system complexity becomes easier to manage as models can be viewed from multiple perspectives. That way, the impact of design changes can be analyzed before they are implemented. MBSE also supports a modular approach, allowing the system to be broken down into smaller systems, making it easier to reuse in other systems, easier to validate, and easier to help detect defects earlier in the system design lifecycle. Using MBSE can also increase product quality, reduce risk, and shorten development lifecycle times. Let's look at two examples that demonstrate how MBSE offers improvement over traditional document-based system engineering. Traditional system engineering processes are often document-driven and event-driven. That is, documents during each project phase are developed to support some program milestone like a system requirements review, PDR, CDR, or test readiness review. On large programs, this can mean that hundreds of documents are generated. Since the data represented in these documents do not have explicit dependencies, a change in one document needs to be reflected manually in all the other affected documents. This manual process is not only lengthy, but also prone to error. Furthermore, when documents are used to facilitate communication, it's difficult to verify their completeness and consistency and to surface conflicting or contradictory information. A contrasting MBSE process is where all teams come together to create a system definition model that facilitates all the system engineering activities. Documentation can then be produced as a byproduct of the model itself. MBSE provides the opportunities to capture and harmonize information from multiple disciplines within an integrated digital model of the system, that single source of truth we talked about earlier. Since dependencies across multiple disciplines are explicitly addressed in the model, a change made in one part of the model is automatically reflected or flagged in all the impacted parts of the model. This makes it possible to maintain consistent and up-to-date information in the integrated digital model. In addition, completeness, consistency, traceability, and contradiction checks can be performed. Let's say Team C makes a change during the early concept phase of the project. Because documents lack explicit dependencies, it's hard to know if other teams or parts of the system are impacted. Any problems this causes ripple down the stream. The result is that problems are found late when they are expensive to fix. Let's look at the same situation with MBSE. Team C makes the same change at the same early stage, but in a system model. This time every system impact is immediately known. Problems can therefore be prevented before they occur or can be fixed very early when doing so is much more inexpensive. Another benefit is that integration and discovery occur much earlier. With traditional development, many of the pieces of a system don't come together for the first time until the end of the project. This makes it difficult to do V&V in early phases. With MBSE, integration occurs digitally inside the model at very early phases. Because the model includes requirements, structure, and behavior, which includes data and parametrics, the model can be used to ensure consistent interface definition, can be used to simulate things like system response to external and stimuli, or explore bandwidth or latency between 2 points in the system. It can even simulate how the system responds under failure modes. This ability allows for problems to be found earlier, which increases the chances of success during your V&V. So what are some of the barriers to entry? There are challenges definitely in not adopting MBSE, and some of these challenges were identified in a recent survey. One is that it requires a significant upfront investment. It does require an adoption strategy. The purpose and scope definition needs to be laid out up front. There needs to be an awareness of MBSE, and there could be resistance to change. There needs to be awareness regarding that. There needs to be executive level sponsorship. There needs to be definition of the methods and extensions. Modularity and reusability needs to be considered up front. How you're going to manage complexity needs to be considered. There's dependency on a particular tool. If you select a tool, you're dependent on that tool. And you need to consider how you're going to visualize large models. So it definitely requires a new system engineering mindset. Engineers with strong knowledge in both MBSE and SE are a rare commodity. So perhaps consider bringing in system engineering experts to support your internal teams in new process integration. Now, understanding the benefits to MBSE and some of the challenges of implementing MBSE, you can ask, is MBSE right for your company? Here's some questions you can consider to help guide whether you want to adopt MBSE in your company. The first is your product complexity high? Product complexity can be characterized in many ways, a few of which are shown here. More complex products produce larger integration challenges, make it harder to predict up and downstream impacts of changes, have more failure modes, can exhibit emergent behavior that is difficult to predict, and generally require larger and more complex development organizations and teams to produce the product. The next question is, does your product operate in a complex environment? Are there strict regulatory requirements or standards that must be adhered to? Are there many external interfaces or a large number of stakeholders that will interact with the product or influence its development and use in some way? Are there multiple aspects to certification that must be considered? And next is, will your product have a long life cycle or be the first in a new product line? Lengthy development cycles of a year or more are typically challenging development projects that may benefit from MBSE. If your development project aligns with these considerations, then taking an MBSE approach may deliver substantial benefits to your company. So how do you get started with MBSE? After deciding that MBSE is a good fit for your company, there's 6 steps, key steps, to help ensure the success of your efforts. First, it's important to ensure that the move to MBSE has support from both leadership, and when I say leadership, I really mean both management and technical leadership. Change is difficult in general. When considering something like moving towards MBSE, that change is as much about culture and people as it is about technology. Success is much easier when there's support from the top and throughout the organization. Get commitment to the cultural and organizational changes. Ensure that there's enough investment in training, investment in infrastructure, and configuration management. Second, it's important to select the right project. If MBSE is a hammer, not every project is a nail. MBSE does require an investment, and the return on that investment will not be the same for every project. The best candidates for MBSE are projects with product complexity, environmental complexity, and those with long product lifespans, as we discussed earlier. Third, it's critical to define your strategy. Many companies decide to move into MBSE and then start out by simply rolling out a tool. This is backwards. It's important to first understand and answer some key questions like, Will there be a single integrated model or federated models? If federated, the information exchange between the models and the teams will have to be somewhat manual. What governs that process? How will you manage it? How and when will training be rolled out to ensure that everyone is ready? How will that model be managed and by whom? How will integration between teams be handled, specifically related to things like common libraries and integration points between different parts of the model? It's important to answer these questions early on. Fourth is to select the right methodology. There are many methodologies out there that are either open source or developed locally by a company internally. One methodology may start with use cases and functional analysis, then consider logical and physical allocations, then data. Another methodology might do it differently. The methodology may also describe how the team moves through the different layers of the system. That is, look at the system level, then subsystem, then component. Regardless, it's critical that everyone on the development team understand what is expected of them, when it's expected, and how their work fits into the big picture. Once all this is known, then you can make an informed decision about the type of MBSE tool that may be needed to achieve your goals. Every tool is different. Many tools are built around certain MBSE methodologies or certain modeling languages. The features and integrations with other tools can also vary widely. Because of all this, it's important to select the right tool for you. Finally, it's important to put experienced system engineers in leadership roles. Leaders on a program should both be the technical and cultural champions for moving the organization forward. Since the direction is MBSE, it's critical the leaders understand, appreciate, and have experience with the foundational system engineering best practices and know how to apply them in the organization. Bringing in system engineering consultants can help organizations in several ways. The first is guidance and mentorship. Maybe your company is just looking into MBSE and wants to figure out if it's ready to make the move, what the implications are of that choice, what is needed to be in place to make sure this company is successful. Or maybe the decision to move to MBSE has already been made and your organization just needs help to roll it out. In any case, system engineering consultants can help walk you through answering these important questions. The second is critical skills, when and where they are needed. It's very hard to find system engineers that understand the core methodologies of MBSE and the different languages and have experience with different tools and most importantly can tailor all of that into something that fits your team. It can also take a long time to develop this combination of skills in-house. Some projects just can't afford to wait through a hiring cycle for people to come up to speed. Outside consultants can be a great option for getting this type of talent quickly for the long term or to help you surge towards a particular milestone. Consultants also offer impartial perspectives and a fresh set of eyes. When the same people are looking at the same problem for a long time, it's impossible for things to get missed. Sometimes it helps to have a new set of eyes look at the issue in a different way. Sometimes things like organization structures, internal politics, or unique company dynamics can limit the way we think about things inside a company. Outside consultants have the luxury of being free from these issues in a way that allows for a broader solution space. Finally, while one or two consultants individually on your project can help in all the ways already described, there's a value multiplier in using these outside consultants. Because each consultant can tap into the knowledge and experience of everyone else at the firm, all with different experiences and areas of expertise, the value that they can provide to your team is multiplied. You also get access to this knowledge and experience, and this can be a huge benefit to any team. So in summary, today we defined what MBSE is, discussed why you might consider using MBSE, discussed some of the barriers to entry, discussed some of the questions you can ask to determine whether MBSE is right for your company, and how to get started with MBSE. I want to thank you for watching this webinar. I hope you got some useful information out of this. If you still want to learn more about system engineering or MBSE, you can check out our white papers, data sheets, and case studies on system engineering. You can find all of our content by going to www.base2s.com/resources. If you want to know more about how Base2 can help your company, you can request a system engineering consultation by using the Contact Us form on our website. Again, thanks for watching. Have a great day. Goodbye.